to explain differentiation by first principle. Differentiation by first principle. Now, we know differentiation is just another way of getting the gradient function of an equation. Once given an equation of a line or a curve, you get the gradient function by differentiation. Now, let's take an instance of this curve. This curve here, we have a curve, then we have this point here with the coordinate x and y. So let's call it point A, coordinate x and y. Then come to another point B with the coordinates. Now on this point from x to B, we shall call it a small change in x. Shall call it a small change in x. That is delta x. Then from this point to y, we shall call it a small change in y. That is delta y. So x, this point B will be x plus delta x, then y will be y plus delta y. Now this point here is x plus delta x, and I think that you can just see from what I'm doing there. Now we want to get the gradient of this line. That gradient of the line AB, will be given by we shall have f of x plus delta x minus f of x. So this f of x plus delta x minus f of x all over delta x. That's the gradient of this line all over delta x. Now, after getting that gradient, we want to see how will we get the gradient function now of the curve. We know that AB is just a line. We want to get the gradient function of the curve. So we get that gradient function by getting the limit as a small change in x, delta x. That is the gradient function of that line. Let's call it the function of that line f of x. So the gradient function will be limit as a small change in x approaches as small change in x tends to 0 of f of x plus delta x minus f of x all over delta x. That is how we get the gradient function of the curve. So the gradient as this delta x tends to 0, then you get the gradient of this curve at the point A.